welcome to Biostatistics lesson topic 2. You are welcome to Biostatistics lesson topic 2, and we are continuing with our discussion in the series of the Biostatistics. We are discussing today contingency tables and association measures. Contingency tables and association measures. We will be looking into this topic, focusing on these following areas. How do contingency tables help assess the association between variables? How do contingency tables help assess the association between variables? This is very important. Number 2 will be seen understanding contingency tables. Understanding contingency tables. And number 3, we will be seeing chi-square test for independence. Chi-square test for independence. Number 4, we will be seeing the measures of association. The measures of association. Measures of association. And when we say the measure of associations, we'll be looking at odd ratios, relative risk. Odd ratios and relative risk. Okay, so let's look into the first one, understanding contingency tables. It's important, so let's see that now. And therein, in the end, we will now know how do contingency tables help to assess the association between variables. Contingency tables, also known as cross-tabulation tables, and they are used to display the frequency distribution of variables. So you can see this is a table, and in this table here you can see this category: smokers, non-smokers, those who came down with lung diseases, yes, 40 among the smokers, 30 among the non-smokers. Those who didn't have lung diseases, 60, 70. Now you can see this is the yes, this is the no. This is the yes for lung diseases, no lung diseases. So you can see it. Among those who are smoking, 40 had lung diseases, 60 did not have lung diseases. Among those who are not smoking, 30 had lung disease and 70 had no lung diseases. So let's continue. The contingency table, they allow us to observe the relationship between two categories. Now, there's usually a structure. The table consists of 2 rows. So when you say row, you see that 2 rows, and then you see columns. I said 2 rows. It consists of rows. It can be more than 1, 2, 3, 4, but it consists of rows, and then it consists of columns. So this is column, and this is rows. Now the rows represent the categories. This row represents the categories, while the columns represent categories of another variables. So the rows represent categories of one variable. These rows, categories of one variable, and then the column represents categories of another variables. So that's that. Now, when you say variables, we are talking of this. These are the categories. These are the variables. That is, lung diseases, those that had the disease, and those who didn't have the disease. Now, what is the purpose of the contingency table? They help in understanding how 2 categorical variables are related by showing the joint distribution of observations. How 2 categorical variables are related together by showing the joint distributions of observation. What is the observation here? Those who had lung diseases and those who didn't have lung diseases. And what is the category? Those who smoked, who are smokers. 40 of them had the diseases. Out of 100, 60 did not. Those who were not smokers, 30 had the diseases, 70 did not have the disease. Example, if we are studying relationship between smoking status and lung diseases, a 2 times 2 or 2 by 2 contingency table could look like this. So this is that. So let's move to the next table so that we continue the discussion there. So next is the chi-square, and you can refer to as the chi-square test for independence. So let's look at the chi-square. The chi-square test is used to assess if there is a significant association between two categorical variables. Now it compares the observed frequency, like you saw there in the two, no disease, yes there's a disease. It compares the observed frequency of occurrences with the expected frequency under the assumption of independence. So we have the assumption, we have the null hypothesis and the alternative hypothesis, and then we go and compare the observed frequency of occurrences, and then in the end we now interpret it in alliance to this hypothesis. So it compares the observed frequency of occurrences with the expected frequency under the assumption of independence. Now we have the null hypothesis. The null hypothesis. The null hypothesis. Now what do we mean when we say the null hypothesis? What do we mean when we say the null hypothesis? I've told you the word not, 0 or O. HO or H0 assumes that null hypothesis assumes no association between two variables. They are independent. There is no association between them. None is dependent on the other. On the case of alternative hypothesis, we can be HA or H1. If you use H0, you use H1 for alternative. If you use HO, you use HA for alternatives. Now, the alternative hypothesis assumes an association exists between the two variables. Unlike the null hypothesis, there is no association that is, observable. There is no association that is existing. So they are both independent. But here in alternative hypothesis, there is a dependence. Now let's see the formula for the chi-square statistics as calculated. You have the S square equals to the expected frequency, and then you have the observed frequency minus the expected frequency, raised to power square, both of them in brackets, over the expected frequency calculated based on the marginal. So this is a sum up here, the S column. So let's look at it again. This formula, it's a widely known used formula, and O stands for observed frequency. The E starts from expected frequency. So this is the observed frequency, and then E is the expected frequency, which is calculated based on the marginal totals. Now you have the degrees of freedom. Now the degrees of freedom for the test is calculated as R minus 1, close bracket, open bracket, E minus 1, or C minus 1, sorry. Now the R means the number of rows, and note this is the rule, like I told you, the rows, the number of rows minus 1, close the bracket. Then you have the number of columns. So this C, how many number of columns do we have? Like that, minus 1. Now, when that is done, there's usually decisions that will be taken. If the chi-square statistics is greater than the critical value that is obtained from the chi-square distribution table, that is at a chosen significance level, which is usually 0.05, we reject the null hypothesis, suggesting an association between the variables. Again, if the chi-square statistics is greater, that is the result obtained is greater than the critical value that is obtained using the 4-figure table, checking the chi-square distribution table, that is the 4-figure table which you all have to get, at a choosing significance level, usually 0.05, then we reject the null hypothesis. So simply put, chi-square greater than the critical value obtained, that is greater than 0.05, will reject the null hypothesis. But if the chi-square statistic is less than the critical value, usually at 0.05, using the chi-square distribution table, we fail to reject the null hypothesis. So we accept the null hypothesis, suggesting that there is no association. So when p value is greater than equal to or equal to the value received, that is the value obtained by the checking of the chi-square distribution table, if it is greater than the p-value of the signal level of 0.05, we do what? We at that point reject the null hypothesis, which means that there is suggesting an association between the variables. Because when you reject the null hypothesis, we say there is no association, we then accept the alternative, which says there is an association. But if the chi-square statistic is less than the value obtained, the value gotten after the calculation is less than the critical value at 0.05, when we simply mean that if p is less than or equal to 0.05, we will fail to reject the null hypothesis. So we will accept the null hypothesis. So in this case, we reject the null hypothesis. In this case, we accept the null hypothesis. So we fail to reject the null hypothesis, suggesting that there is no association. Very simple. When the value, the p, is greater, that the value obtained is greater or equal to 0.05. At that point, what do? You reject the null hypothesis, which suggests that there is an association between the variables, which is then the alternative. But if the chi-square statistics is less than the critical value, then we will fail to reject the null hypothesis, which simply means we accept the null hypothesis, which suggests that there is no association. So you see things like p less than equal to 0.05. When you see that, it means that we accept the null hypothesis. When you see p is equal to greater than equal to 0.05, what it means is that we reject the null hypothesis to accept the alternative hypothesis. Now we move to the next one, which is the measures of association. Don't worry, you will see the other videos which I have uploaded. Those videos are from friends, from mentors, colleagues who are very good in this, and because there is a practical explanation. Now you can easily watch it, repeat the calculations as they do it, and then that way you understand it. I can't start doing that right now because of the technology. I cannot just start writing right now on this board. But I have given you the very background so that when you listen to the video lecture, you will understand with ease. So once a significant association is detected, it is important to quantify the strength and direction of the relationship between the variables. And here are some common measures. Now, after you have gotten it, we want to know the strength. We want to know if this dependence, if it is a rejection of the null hypothesis, confirming that there is a dependence and association significantly between the variables, then you want to know the odd ratio. You want to compare the odd ratio to know how clearly the level of strength of that relationship is. So we use the odd ratio, and then we use the relative risk. Now for the odd ratio compares the odds of an event occurring in one group to the odds of the same event occurring in another group. So it will compare the odd of this thing occurring in this group and compare it in this same group to see that is it really strong? Is it of a high strength? Can it occur here and still occur in this group? where A is the number of occurrences of the event in group 1. You can see it here. Example, smokers with lung diseases. And B, number of non-occurrence in group 1. Example, smokers without lung diseases, smokers without lung diseases, like that. Now, that is the B. Then C, so you have A, B, C, D, like that. A, B, C, D. You have the smokers, non-smokers, as you saw in this place here. So you can see the smokers, the non-smokers. So it's A, B, C, D. So it's very important that you have an idea at that. Number of occurrences in event in group 1. Example, the smokers with lung diseases. Example again, B, number of non-occurrence in group 1. Example, smokers without lung disease. Now C, number of occurrences of event in group 2. Example, non-smokers with the lungs disease. Then D, number of non-occurrences in group 2. Are you seeing it now? Now C and D is dealing with the group 2 here for the smokers and the one under non-smokers. Very, very important. So you have A, you have B under, then you have C, and you have D. Now, what is the interpretation? If the odd ratio is greater than 1, there is a passive association or positive association between the variables. Higher odds of the event occurring in the first group. That is, there's a higher probability, a higher odd of the event that we are looking into occurring in the first group. Now, if the odd ratio is equal to 1, then there is no association. But if the odd ratio is greater than 1, then the probability that it will occur is high. But if it's equal to 1, there is no association. But if odd ratio is less than 1, then it means that there is a negative association. Negative association. Lower odds of the event occurring in the first group. That is, there is a lower chance that it will occur. If it is greater than 1, there is a higher chance that it will occur. If it is equal to 1, there is no association established. So let's move to the next slide. Now we want to talk about the risk ratio now. Relative risk now. Relative risk. Now, relative risk compares the probability of an event occurring in one group with the probability of it occurring in another group. It is commonly used in cohort studies. But in odds ratio, it is checking the probability that this risk will be higher here or lower here. There we are looking at the rate at which the strength of such occurring. So that's what we are. But in relative risk, we are comparing the probability of an event occurring in one group with the probability of it occurring also in another group, and it is commonly used in cohort studies. So you can see the formula here. Relative risk is equal to risk in group 1 over risk in group 2 is equal to A. Remember I told you it is this way: A, B, C, D. So you have group 1, column 1, and then column 2. You see now, category like this, category like that. So now risk in group 1 over the risk in group 2. Then you now have A divided by, open the bracket, A plus B, that is A, B. The value here, the mean value here, the mean value, the mean. So I'm giving an example like A imaginary, B, C, D. There's a quadrant like this. So at this point, this is the what? The column, and this is the what? The row this way. So that's that. Then you have C divided by open bracket C plus D. A divided by open bracket A plus B. So number of events in group 1, that is A. Number of non-events in group 1, that is B. Because this is the event, and then this is not event. So like that. So that is that. Then C, number of events in group 2 and number of events of non-events in group 2. 2. So that is A, B, and C, D. It's very, very important that you understand that. When you see the table, you will understand once you see the grouping in that table. Now, if the relative risk is greater than 1, like I told you before, group 1 has a higher risk of the event. If relative risk is equal to 1, both groups have equal risk. Unlike the other one, there is no risk associated at all. That it will not occur. The odds that it will occur is none. It will not occur. But in the other one, in group 1, it says that there's a high probability that it will occur. In this case, there's a high risk of the event occurring. Now, in R is equal to 1, relative risk equal to 1, both groups have equal risk. In the both groups, they have equal risk. Now, if R is less than 1, group 1 has a lower risk of the event. That the chances that it will occur will be very, very low. So that is that. So let's see in conclusion, contingency tables are useful for summarizing and analyzing the relationship between two categorical variables. While the chi-square test for independence helps determine whether the variables are associated or independent, the strength is where odd ratio comes in, and the level of risk is where the relative risk comes in. That is, on the event that thing will occur. Now, the odd ratio and relative risk are key measures that help quantify the strength of the relationship. That to what extent can it occur? First, in the other group in form of in chi-square, and 2, between two groups occurring between the two of them. At what level will it occur in both groups? Now, understanding this concept will enable you to analyze categorical data effectively and draw meaningful conclusions. So, I will advise at this juncture that in collaboration with mentors, I have provided 3 videos. One of them will talk to you about the contingency table, and the other will talk about the measure of associations, and the other will talk about chi-square test for independence, and it will break it down to its minimum, PRS understanding that you will pick. And I tell you, you are going to enjoy biostatistics, and you will never forget this class. Remember, like I told you, open up your mind, just love the course, freestyle on it, listen to the lectures, and ask questions when you need to ask questions. Watch the videos, write down your notes, draw the tables, and you will understand everything I've said as the calculation is made explained to you. Thank you, and remember to make sure that you do the needful in terms of attendance, and also to subscribe if you enjoyed this video, and if you were really impacted with this knowledge. I'll see you in the next video. Bye for now. Once again, my name is Dr. Henry Isaac Boy. Bye.